Hello everyone and welcome to today's Elektor webinar, OBD2 meets LoRaWAN, real-world IoT for vehicles and sensors. I'm Brian Tristam Williams and I'll be your host. Today we're looking at how real-time vehicle data and long-range wireless communication come together in practical IoT systems. But as always, we have a giveaway for our viewers. Show that off to you. It's the OBD2 CAN bus development kit, which is very appropriate for today's show. It's a plug-and-play kit for DIY diagnostics, vehicle data logging, and CAN bus experimentation. It works with Arduino, Raspberry Pi, and other platforms and comes with everything you need to get started. So stay tuned, because at the end, you'll get the keyword that I'll reveal to enter this competition. So that is pretty exciting. I wouldn't mind one of those myself. Before we move on with today's show, I want to talk about our sponsor, EE News Europe. If you're looking for the latest electronics and engineering news, check out EENewsEurope.com, which is an Elektor international media publication. EE News Europe is a fully digital publication covering the global electronics market with specializations in analog, automotive, embedded, power, smart 2.0, and wireless technologies. Read EENewsEurope.com and subscribe to its newsletters to stay informed about essential industry news, key events, and technical innovations. That's EENewsEurope.com. And if you're interested in today's show, you can just search for OBD2, and there's plenty for you there as well. Our guest today is Saad Imtiaz, Senior Electrical Engineer. Saad couldn't be with us live today because it's a national holiday in Pakistan, but we prepared this very insightful webinar to you. Saad has a background in mechatronics and deep experience in embedded systems, product development, and prototyping. He's worked across startups and global enterprises alike, building everything from custom automotive dashboards, like the one he'll show us today, to solar-powered LoRaWAN nodes. Before I hand over to Saad, let's just say hello to our audience. We've got people from all over the place. We've got Stephen from Dake in Curaçao, of all places. We've got Karsten Stellmacher in Aachen. And I see we've got Alexander Neumann, and wow, it's hot there. Alexander, where you are in Bensheim, it's 34 degrees. In the Netherlands, it's 31. Here in Johannesburg, it's only 22 degrees outside, but with all these lights and equipment, I would say it would probably be hotter in this room if I didn't have air conditioning. Well, that should be fun. So now, with that, let's hand over to Saad for his webinar. OBD2 meets LoRaWAN, real-world IoT for vehicles and sensors. Over to you, Saad.
Hi, everyone. I'm Saad from Elektor, and today I'll show you how I built an ESP32-based OBD2 dashboard, what worked, what didn't. I'm going to share a quick roadmap of how things are. But firstly, we will talk about OBD2, what it's itself, and then we will going to talk about how to build one. So why build an OBD2 dashboard? First of all, generic dongles and phone apps which connect with each other are not great. Some are paid, some have a terrible UI, other not exactly what you wanted, and so on. But dedicated dashboard gives you control over latency, layout, and what type of data you prioritize to see. For me, this began with my 2001 Land Cruiser. Watching the slow needles, as you can see on the screen, the coolant and the battery, oil pressure, temperature was slowly going up, and me thinking that it's an old car, maybe the sensor is bad, or what's the actual reading. So that made me pull the exact values from the ECU and show them on an embedded display. Okay, so what is OBD2? OBD2 is your vehicle's built-in self-diagnostic system. It's a standardized protocol that allows extraction of diagnostic trouble codes, known as DCTs, and real-time data to the OBD2 connector. At the right side, you can see a picture of an OBD2 board. It's normally under your steering wheel, and it can be hidden at sometimes, but most of the times you can find it easily under the driver's side. So a real world example will be, I would say, you've probably already encountered with an OBD2. Uh, you might have noticed quite so often or very rarely a malfunction indication light on your dashboard, and then which is actually telling that there is an issue with the car. So you visit your mechanic and he uses an OBD2 scanner to diagnose the issue. To do so, he will connect the OBD2 reader to the OBD2 16-pin connector, which I showed in the last slide. And he sends the OBD2 request to the car, and the car responds back with OBD2 responses, which contain fuel, speed, fuel level, speed, and other DCTs. Some codes can be about something wrong with your oxygen sensors or fuel lines, or even ABS or braking, and so on and so forth. So it makes point at the right direction in terms of finding and troubleshoot the problems faster. So what's behind those 16 pins? Well, the main reason why there's this connector here is to access data from the ECU. So this is a specified standard known as the SAE J1962, also known as the ISO 15031-3. So in the illustration you see on the screen, this is a type A OBD2 pin connector. And some things to consider, some of the pins, not all 16 pins will be shown in your OBD2 connector, because some of the screens are, some of the pins are manufacturer specific, but the most of them you will see as a 16th pin will be 24 volts, but in some cars it's also 24 volts. So if you're starting to power your circuit or something, you're connecting to the OBD2, you have to check it first for sure. Then 4 and 5 will absolutely be ground, but let's say the ISO, a CAN high and CAN low, the K line, the L line, and the SE bus, these, not all three of them will be shown or will be provided by your manufacturer, but most of them will be. Yeah, 16 pins always will be powered by the battery voltage, and all these protocols depend upon what your manufacturer specifies or provides you with. So this is not everything. You cannot control your airbags or brake systems. That's out of scope. But yes, it will provide you data about the airbags or brake systems, as in if there's something wrong with the airbag or there's something wrong with the brake system. Yes, but you cannot modify it. But mainly it's for emissions and the engine data. So RPMs, load, temps, other sensors in the car. So protocols, mostly you will see a CAN protocol, CAN bus protocol. In motor cars, it will be CAN. In some of the older variants, it will be a single wire K line. And in some of the old American vehicles, it might be a PWM J1850. And sometimes you will find all of these protocols at once in the same car, or sometimes only one or two. But the cool thing about using a dongle like the ELM327 is that it auto detects which pins are alive, so it's easier handshake with you if you want to make something from it. So the way the OBD data works is on request. It's not continuous data stream. You're not tapping into the live communication between the car, but it is like you send a request and then you get a response according to that request. So first of all, in order to get live data, the mode is 01, and then the PID. So let's say the PID for RPM is 0C, And first you have to, if you're sending this command to the ECU, you will, let's say if you're typing, I would give an example if you're typing. So 01 is the mode. I want live mode, and I want the RPM at that exact moment. So we send this to the ECU, and in response we get 4.1, which is a header, and you will always get 4.1. And then 0C is that it's responding that you asked about the RPM. So this is the response for the RPM. 1A and 5.8, sorry, F8 is the data. So you have to convert it into decimal. So basically you the formula is given. So you have to, the formula for each let's say response is different. So you have to go through it, find which PID you want, and then the response to it, which bytes you should consider to converting into decimal in order to get the right value. So yeah, after calculations, you will get an RPM for this. I believe it will be 1,726 RPM. So all the PIDs are standardized, but not every car supports every PID. So it can be that oil pressure is displayed on your dash, or maybe it's not, or maybe it's not displayed on the dash, but you can see in your on the scanner. So there's always a checklist which is available. I believe in your manual, or if you search your car on the internet, which PIDs are available, you can find that. So for the OBD2 dashboard which I made, it was very simple, 3 picks I did. First one was an ESP32-S3 touchscreen, 3.5 capacitive touchscreen. I found it because it's aesthetically pleasing. It was really easy to work with. It has touch system as well, really good contrast and colors. Second, most obvious pick was, of course, the ELM327. It was the double PCB variant. I will get on that later, which to choose, which to avoid. This one specifically because it uses a PIC chip, and also it exposes the UART parrots, because there's a PIC chip, and then above that there's a Bluetooth module. There's a separate. And then, of course, a USB cable to power your ESP32-S3 display, and a 4-core wire for the UART to connect your ELM with the display. And that's pretty much it. So the ELM works as a translator. It detects the vehicle protocol, talks to the ECU. You get gives us a clean serial interface, and then that is fed into the ESP32-S3. Then you can have a nice TFT UI, and then you can, if you want, you can add built-in touch or store values on the SD card, and so on and so forth. Okay, so choosing the right ELM327. First, before bringing the project, I bought a bunch of ELM modules, but first I just bought only one, and I plugged into my Land Cruiser, and nothing was showing up at all. I thought it's a bad ELM module I purchased, so I bought 2 more, and same story with all 3 of them. There was no communication, and after struggling, trying to find out, maybe there's some other one I have to purchase, but all of a sudden I realized that let's check the connector. Maybe that's bad because it's an old car, and I found out there was only one K-line connector, K-line protocol working, and there was no pins connected at all. So yeah, it was hard luck. It didn't work, but when I plugged these connectors on another car, it was perfectly. So on a 2007 Honda Civic, it was working. On a Prius, it was also working. But yeah, choosing the right for this project specifically is important. So as you can see, these 3 ELM modules, all of them have the outer shell, plastic shell is different, but the inside chip is completely the same. There's a little bit PCB difference in 102, very small, but they're all using the same Chinese chip. I was not able to find it on the internet. Um, so I was not able to find out what are the UART pads so I can use it. But I came across the this 2-layer PCB ELM module, where you can see there's at the bottom, there's the PIC, which does a PIC chip, a PIC chip, which communicates with your ECU. And then you have a Bluetooth module. And the microcontroller at the bottom communicates with the Bluetooth module on the top via the UART. And so we basically attach the wires on top of it with our 4-wire connector. Ground, of course. You don't have to attach 3-volt line because you're powering the ESP32 via Bluetooth, via the USB connector from your car. So you don't have to power it directly. Yes, and RxTX for sure. So at the end, you will have this nice contraption with the 3 wires. 4th wire, the power is not connected, and the display I chose already has a bunch of I/O already. So you have a speaker option. You have a lot of I/O here. I use this one for the UART. And yes, you have the SD card. You can attach even a battery, and there's another option as well for another connector. So this is JST 1.25 pitch connector. I'm not believe which type is it. It's a XH, but yes, you can search it on the internet, and you will be able to find which type of connector it's used. So why UART? So first of all, I wanted to use wireless, but the point is I wanted to use that display, which only has ESP32-S3, and ESP32-S3 only has BLE, no Bluetooth. So if you want to have a wireless connection with this ELM module, you can use a normal ESP32 display. I would say that that cheap yellow display out there, that will easily work with this ELM module with Bluetooth. So instead of fighting protocols, I just went with the UART, a rock solid connection. And it's a little bit boring, but it's the best way. You don't have to play around with the connecting and typing in the MAC address to connect directly to this ELM module and so on and so forth. So you have to do a little bit more if you're connecting via Bluetooth. So firmware architecture is pretty much very simple. Simple request parse and then render loop. It's connected by UART and some Arduino GFX library to make the display. So before we hop into the code, let's just look at the PID math. So these are some of the examples shown, or the parameters with their PIDs. Notice we're going for the live or the most recent value. So the mode is 0, 1, but the PID for coolant temperature is 0, 5. The formula for is A minus 40. And this is the response we get. So 0, 5, 7B, and I will get into that later, which ones to look at and which ones to completely ignore. So we have the same for RPM. The speed is directly the same, throttle, and other sensors as well. So there's this tool which I really liked. It's by CSS Electronics, and they have this nice converter where you can select the PID here on the left side, or you can just simply select the name or the parameter. So let's say vehicle speed. The request you will be sending is 010D, so 0D. And you will be looking at third byte, which is 3C. Here it is 3C as well. So you will be ignoring 0D, and you will focus on 3C only. You will convert into decimal, and you will get the kilometers per hour. So the block diagram of the project is pretty simple. The ELM module is connected to the OBD2 port. The PSC handles with the CAN bus interface. And then we're tapping into the connection between the Bluetooth and the UART. And we're sending the command for the coolant. And we're getting a response. And then we will be converting all the values and everything on our ESP32. So if you're tapping into UART, I was not able to connect it with my phone. So if you're connected to the phone, I don't think I was not able to show the values on my display. So I think only one thing works. I'm not sure why, but I have to further investigate to comment on that. So yeah, let's start with the code a little bit. So you're requesting the ELM module. You're sending 0105 coolant. You're getting a value, and then 41 confirms that it's a successful response. 05 is the specified PID for the engine coolant, and 7B is the data of the coolant. So I have to clean the response first. Before we, I'm gonna be going right now. I'm going through the code a little bit faster, but if you check the GitHub repository for the OBD2 dashboard for this project, you can easily go to the code, and it's pretty very simple to implement. So so we clean the response. We are converting the hex into decimal with a small formula, and voila, you got 83 degrees Celsius. And to show it finally, I used a function and the draw coolant temperature, and inside is just making a card, placing the card at the right place, some logic there to change the color if it's over a specific temperature, and it displays on the screen. So here is an image of all these values displayed. What I placed is that sometimes there is a small hiccup. Very rarely you do not get a value. So I simply made the car disappear. If there's no value, that car will disappear. So there will be a black instead of a card there. So for the UI, I went through a bunch of car racing displays, and of course I don't want an RPM meter in this because first of all I really wanted it, but the speed, or I would say the refresh rate of this display was not the best. So I just completely ignored that, but the other sensor value part is very valuable for me. So yeah, I designed this display concept on Figma. So here, selecting the right display size and then starting to play with how to play stuff. It's completely, you can make however you like. I went with this display. It's very clear to see from the driver position. You're not squinting your eyes in order to read a value. And yes, displays everything I want. So that's good. The other thing I added is the uptime. I wanted actually to add more stuff here in order to show some DCT codes, but as of now, we're just collecting data, live data, and showing on the display. But I plan to make such a code which taps into a DCT when it occurs. It shows here in order to, before I plug in or connect it with my phone to see or scan it, I can just simply see it here and what's the problem, and I can solve the issue. So other things which we can add, as this ESP32 has SD card reader, you can do SD card logging. You can save the plots in a CSV file, and then you can see how's your engine data working and other stuff, which will be nice to see. So enclosure and 3D printing before, so the display itself does not have an enclosure or a way to mount it with your car. So there's some effort in making an enclosure and 3D printing it. So basically I took a picture like this with a ruler next to it. to get the exact dimensions, and designed it in SolidWorks. So yeah, I first made a rigid structure, but that didn't work out because the angle where I sit, it was this display was facing a little bit downward. So I added this pivot to adjust it for the viewing angle. Here's another back shot for it. So yeah, the two wires are coming out of this board. One is going connecting with the UART with the ELM module, and one is the USB Type C. So this is the placement for the USB Type C and the UART. So at first, I just simply made a solid 3D print with the base plate and the support bar. So yeah, this melted all of a sudden after 2 days when I parked my car in the sun, came back, and this was all deformed. First problem was, of course, yeah, I didn't use a good amount of infill. And second, I used some epoxy to join it, and the epoxy I used was not temperature resistant. So so it melted again. So in the version 2, I plan to make this entire stand in PETG and 70% infill, and with 2 screws at the back, M3 with the heat inserts, and M3 screws, and which worked fine. Here's an exploded view of the 3D model. But yes, factors to consider while 3D printing. So yes, cabin heat in summers reaches from 60 to 90. I believe in Pakistan it goes beyond that. But yes, so you have to consider that factor for sure. PETG is the best one you can go for. It's a really safe bet, heat resistant. And if you go with black or dark gray, it has good UV protection. But yeah, if you have an enclosure with your 3D printer, ABS is a really good choice as well. But I would not say go for PLA. It's not your best friend here. So with the PETG, I would say the most important thing is you keep the infill from 50 to 75%. If you can go 80, that would be nice. Go for grid pattern or gyroid, and have 5 to 6 top and bottom layer. So nice solid layer from the top. So if you don't want the holding part to be screws, you can use some temperature resistant glue. I believe that would work. And yes, to finally top it off, I would recommend you do a nice automotive clear matte spray paint on the enclosure. So here's a picture of mine. This is was printed in gray PETG, and I printed it black, but the black paint I did was not automotive grade. So if you want a better result, I would say apply some putties to reduce the layer lines and a little bit of sanding, and then paint it, and it will be good. Here's a picture of a recent reader who shared this with me, and he didn't face any issues making this dashboard and was really happy with it. I believe this is a SLK 200 Mercedes, and he said there's slight, he had to change the formula, of course, because of the engine change. You have to change the formulas for the average, we'll say the fuel consumption, the mass airflow sensor, and so forth. But if you're getting this data from the ECU, you don't have to play around with formulas. but in my Honda Civic, I was not getting any instantaneous fuel consumption. So I had to play around with it with the formulas in order to get out the correct value. Well, you cannot always predict or confirm that this is the correct value, but according to my testing, it was pretty much very close. So future upgrades will be, yeah, the roadmap is that I can configure it with a web server. I can select the right cards for the right PIDs, SD logging, then some voice alerts if temperature is high of the coolant or some other DCT occurs, then a GPS and an OTA for sure, and long range with LoRa and telemetry and other stuff. So another thing which I'm looking into for this project is adding long range with the LoRaWAN, and integrating it with the LoRaWAN sensor node V2. If some of the readers are familiar with this project, I did a project before the V2. It was the V1. Here's a screenshot of that. So basically, it was ESP32-C3. It had some connector, some sensors with it. It was connected to the TNN network, and the LoRa VIO E5 module, and there was a bunch of power consumption optimization in this project. So the V2, this one, the V1, was modular. So a lot of modules were connecting with each other to one main expansion board, SHA expansion board. But in the V2, I plan to make it a one PCB, so which will be, of course, an ESP32-S3. Then for LoRaWAN, a rack, a 3172 LoRaWAN module. I will be integrating a GPS module as well from eByte, the EWM108 GN005, which gives you a lot of GPS protocols as well. Then, yeah, it will have a bunch of power consumption features as well. So here's a block diagram of that system. So as this sensor node can be used in the field as well, but it can be also integrated with this. Of course, we're not using solar panels to power this, possibly USB and a battery as a backup. There's some timer ICs, but you can bypass that as well. Then, yeah, in order to save power, we're using load switch ICs in order to turn off the modules we're not using at the current time. So let's say if your car is parked or for a long time, or you don't want your battery being drained, car battery being drained, so you can have a backup battery with this sense node. So combining these two things, I would say you will be getting the best of both worlds. The OBD2 dashboard is your live co-pilot showing in the load and coolant temperature, speed, and in the background, LoRaWAN node wakes up time to time, grabs a summary of the dashboard, tags it with the GPS location. And as now there's a really good LoRaWAN network in Europe, and also it's all around the world, it's increasing. Using a SIM card is okay, but this is I would say a really easy option to implement. So it will be a really good place to start with the store summaries, where you went, how much time it took. I like to dive into that information. But yeah, if someone has a bunch of, I would say, rental cars, you can use this, or other solutions as well. So closing thoughts. So taking the vehicle to the next level in terms of telemetry and getting the data you see. the OBD2 dashboard keeps you in the loop while with live readings. Can also log trips, give you summaries over covered distance, the fuel average, fuel economy, and other performance trends. So if you have a problem with your car, you don't have to connect OBD2 scanner. You can simply view the stuff on the display itself. And finally, I would say the LoRaWAN is another good thing in order to monitor your car. And that's pretty much it. I would say SD card would be really nice to be integrated, and also some alerts. So in some of the cars, if your engine oil needs to be replaced, it has a due light. So instead of you having to remember that or keeping a logbook, you can have some alerts set up with the LoRaWAN or other Wi-Fi onto your phone, and you can get an alert every time if you have to replace, let's say, your battery or change your oil, or even, I would say, any type of maintenance activity you need to do. So thanks for sticking around with me. I'm happy to really deep dive into any part of this build, and I would love to hear from you guys and what you create.
Great, thanks, Saad. What a great project you've done there, and a fascinating deep dive, literally down into the car's innards. Your car is a 2001 model, and you showed one redescent in a Mercedes adaptation for your project. Is it just 100% compatible based on the protocols, or did he have to update any of the firmware?
Not at all. He just had to update some of the formulas, but for the PID, each and every car follows that same PID. Not all PIDs are offered by all of the cars. So let's say if your old car or any car does not has a sensor, let's say it will have a mass Fourier sensor, but let's say if it doesn't, it will not respond from that PID. So only that thing won't work. But apart from that, yeah, it will physically same protocol, same code, everything will work.
Awesome. And I like the board that you chose. It's not a short name. It's JC3248W535. How long did it take you to settle on that particular development kit?
I was actually searching for displays, and when I came across this one, it had a nice minimalist type design. If you see other boards, some are square, some are really differently built, not good quality. This one was ESP32-S3 and a good display size, good flash memory. So I just went with this one. So I thought maybe this might look amazing when I put it in my car.
Oh, yeah, it is amazing. And it's so cheap as well. I think about $15. And, I'm used to buying screens to plug into microcontroller boards, but this comes with the ESP32-S3 onboard, plus the screen, plus everything. Just a question about the rear. I saw you showed a raw back end. Does it come with this back cover?
Yes, it does. But I took it off, of course, because I'm using a back plate myself. But as you can see, you can still see the screws, screw placement on its four sides, where you can mount another back cover in order to mount it on the wall, or like a dashboard stand if you like.
Well, that's great. It's quite an exciting little board. And I have a car with OBD2, which I've always wanted to experiment with, but haven't got to. So I'm glad that you've given me the doorway into that. You only worked on your own cars, is that right?
Yeah, I tested my neighbor's car as well, and it worked. But yeah, we have a Mercedes. I didn't check it on Mercedes. I thought I was a little bit skeptical about, hey, if it's gonna work on a Mercedes or a German car, but it did. One of the readers tested it and was really happy with the project.
Awesome. And for your planned voice and GPS logging, what's the biggest technical hurdle you think you're going to face for your future upgrades?
But first of all, getting the DCTs and recording the right sound. I believe I can use now AI to generate these error responses or voice alerts. Um, it's just getting the time to get this project a little bit next step ahead. Um, I don't think there will be a specifically problem to add these features. These are really simple features to be added.
Great. And have you thought of, in terms of future upgrades, would it be of any utility to use AI to analyze the CSV data to maybe pick up on problems ahead of time or to alert you to things like that?
It is possible for sure. I mean, we're looking, there are even some AI models trained now to detect vibration and sound. And if you didn't make a model which is really good trained with these sounds, like it's a fan belt sound or something wrong with the vibration or anything like that, yeah, then you're easily able to generate these type of alerts as well, for sure.
Amazing. So you can analyze more than just OBD2 data, but audio as well. What about accelerometers and maybe suspension data? I know I'm being a bit ambitious after you worked so hard on this one and it's working great, but I'm just thinking future.
It's a lot of work. I mean, anything with AI these days, you have to get a lot of data in order to make a model, and not just generic to one car, but many cars. So it's, I would say, you need to be I need to be a complete company with a lot of employees, and we rent cars and do testing. So yeah, if someone wants to do that, yeah, it is possible for sure.
Oh, great. Please don't start a company because we don't want to lose you. As for the firmware, was it completely running bare metal, or did you start with some sort of basis?
It's completely bare metal. So yeah, we're using just the graphics library, and then we're just using UART. The rest is just simple programming and formula converting. So it's and just only one library was used in this code.
Okay, and on the OBD connector, I see that there was chassis ground and system ground. Are they typically connected together or are they separated?
I believe they are. In my scenario, they were, and they should be. But I'm not sure. I cannot give an expert opinion on this. Maybe there's a way, but I think they should be connected. Otherwise, there might be some ground loops or some things like that might occur.
Okay. You obviously studied a lot about the PIDs, and given that the vehicle you were working on was 24 years old, has that been upgraded? Have there been more features added to OBD since then?
OBD has a history. So before OBD2, there was another protocol, I believe, from '96. Like, I would say America, the American vehicles had a different protocol, then the Canadian was different. EU had different for petrol and diesel. And finally, they all joined hands and create one connector, which is the OBD2 standard. So this is the history of that. So before that, they had different type of connectors for different type of cars. But now finally in 2010, I would not 2010, I think a little bit before that, all vehicles are now supported with OBD2. So from, I believe, 2008, it's completely mandated for all cars in the US. In 2003 was mandated for in diesel cars in the EU. But I'm not completely sure I'm on the information, but you can definitely check this out. But from 1994, this was a standard. It was a standardized protocol, but a lot of companies took a little bit of time to implement into their cars.
Okay, so my car comes in just after the final mandate. It's a 2009 model. So I'm definitely
It will probably
try
have, yeah. Which brand is it?
It's a
or manufacturer?
Fiat Punto Grande, 2009.
Possibly, it will have OBD2 connector for sure. And yeah, easy thing is if it's EFI engine, it's gonna have an OBD2 port. If it's carburetor, old car, I don't think so.
Awesome. So nothing for a Pontiac Trans Am 1982, unfortunately. But yeah, you mentioned having trouble getting it connected via Bluetooth to your phone.
Yes. So with my phone, so there was a problem with the car. The car was not supporting the OBD2 port or the protocol which the ELM module supports, but it had a OBD2 connector, but it was not communicating with the ELM. With the so with the project, with the current project, if you're connected to the display with the ELM module, if you try to connect with that Bluetooth module of that ELM, you won't be able to connect with your phone. You have to disconnect from the display, and then you can communicate with the ELM module.
Okay. And were you considering using off-the-shelf standard OBD2 app on the phone, or were you going to go write your own?
For starting, for just testing purposes, I went with the phone app to check whether this module works or not. But the thing is, if I'm gonna use an app on my phone, and I'm gonna have to mount it at some point, I'm gonna have to detach it, and I just don't want my phone to be on the dashboard at all times and deattaching. I normally put it in the glove box while I'm driving, and it just connects with the multimedia display or the panel where you can dial buttons or see Google Maps. So I don't want it mounted anywhere. With this, it's a light, very light system. You can connect it, and it can stay in your car. It's no disconnect, connect again, attach. So it's just negates all these, I would say, processes you have to do.
Great. Well, that was an excellent project. I wish you all the best with the upgrades that you want to do in future, and I look forward to seeing what comes out of that. Thanks for your webinar, Saad.
Thank you.
And that was a great webinar by Saad right there. Let me get back to the giveaway as I promised I would do, and then we'll have a look at some of your questions. As I said earlier, we're giving away this perfectly appropriate giveaway for today's show. It's the OBD2 CAN bus development kit. And if you visit our giveaway page, elektormagazine.com/elektor-webinar.giveaway, the code word for today is OBD-II or OBD2. So go on over to the page, enter the competition, and good luck. There you see it on your screen. The URL to visit, drop that in your address bar, and the code word OBD2. Okay, now let's have a look at our audience questions. We've got people from all over the world here, where it's a heat wave in Europe and it's winter down south here. So thank you all for sharing your temperatures with us, including Frank. He's a loyal viewer, so I'll just put his comment up here. Very sunny in the shade, 34 degrees in Velen, Belgium. Same in Germany. Okay, let's have a look at these questions. A very insightful comment from Jack Kersing. He says, is there no electrical issue with both the ESP and the Bluetooth module TX connected to the module RX? So yeah, I think so. If you tie two TX lines together, like the ESP32 and a Bluetooth module, both going into the ELM327, they will fight each other. That's if the Bluetooth module is talking. You'll get garbage data, maybe even stress the chips. Safeway has one host at a time to use a little multiplex or a switch to pick which one's talking. But in Saad's case, as he said, he did not use Bluetooth because he was unsuccessful, so there's no clash. And I don't think that Bluetooth module talks if you're not asking it any questions. Question from Jürgen Zick. How about something similar for NME A2000, the networking in the marine field in boats, which is very much alike? There is more data to visualize, e.g. from the GPS and autopilot. You're bringing back memories, Jürgen. I built a GPS circuit from Elektor about 25 years ago, and that's before we had convenient GPS on mobile phones. So it was plugged into my laptop. I think it had a USB output, and I drove around on the highway, and we didn't have the maps, we didn't have Google Maps, none of that, just the plotting, and I could plot the highway. So yeah, NMEA 2000 on boats is basically CAN bus with a different rule book. So same principle, you can tap in, read the messages, and put stuff like GPS, autopilot, or even depth data on a screen. So the same approach could work in the marine world too. Nice. Also from Jürgen, how about using LoRa and Meshtastic or MeshCore for radio amateurs, Meshcom? There, the mesh systems offer usually MQTT brokers where your data can be updated easily. I think that's also a neat angle, Jürgen. Saad's project already looked at LoRaWAN for long-range telemetry, but you're right, if you drop it into something like Meshtastic or Meshcom, you get the bonus of a mesh network and even MQTT integration straight out of the box. So that would make it super easy to push the car data into a broker and have it show up anywhere. So it's totally doable. I think Saad was using CSV for starters. It just depends if you want point to cloud like LoRaWAN or a community mesh where everyone's nodes help carry the data. Very interesting. Question from Klaus. Where to find the PIDs, for example, getting dates from EV, battery state data from the EV, the battery state, etc. Well, the first point I would point you at is Saad's article in Elektor magazine. It is in the July-August edition. And a lot of details there, where you see that UART conflict that we were talking about. And Saad does link to PIDs at the end of the article, but also helpful answer here from Jürgen is to go to Wikipedia and start there. What other questions did we have? Demetrius, where are you? There we go. With the magazine. You're only looking at chosen generic OBD2 data coded into the source code, or is there a way to configure what one wants to see in a running system? So, right, that's exactly as you guessed. The code has a fixed set of PIDs hard-coded in, so what you see on the display is whatever's in the source. Saad does mention in his article, though, that one of the next steps is to add a little web-based config page. Like that idea. That way you could pick and choose which sensors to show without refreshing the firmware. So today it's static, but the plan is for it to be configurable on the fly. Nice comment from Stephen over in Curacao. Inspirational project. We have a 2009 Hilux with a failing dashboard and an issue with obtaining a replacement. Good luck with that, Stephen. Suggestion from Wilfred, you could use a magnetic phone support instead of a specific support. I think Saad just really wanted to use his 3D printer. You know how it goes. When you've got a hammer, everything looks like a nail to you. And Wilfred also says, thanks for the presentation, gives ideas for personal projects. And also Jack, well spotted again, the Bluetooth module will still drive the output if it is not open collector. Maybe use 2 diodes to avoid the outputs fighting. I would say, yeah, that's a good idea. For some reason it's working for Saad. I think that could be because the UART is active low and the Bluetooth module is probably holding it high, but without too much aggression, if I could put it that way. Pleasure, Demetrius. And from Jack again. LoRa usage limitations depend on frequency used. EU is typically 868, and there's 0.1 or 1% limit on airtime usage. Interesting. And Justin says, very interesting, I'm interested in a dashboard showing the detailed battery and inverter status on my Tesla S. Jürgen, back with more insights. LoRa, depending on the used band, has restrictions. For hams on 433 megahertz, there are none. On 868 megahertz, they are, depending on the specific band. Here's a useful link from Mike. rfwirelessworld.com/calculators/LoRa data rate calculator. I would go there if I could, but that's a long URL to type in right now, and this app doesn't let me copy and paste. Anyway, I think we've come to the end. We've got some very great questions, some great insights. Saad's going to be interested to hear about that UART contention issue on the TX line. But we'll let him have his time off. It's late in Pakistan right now, and it's a national holiday there. So I want to thank everyone for joining us from around the world. And I hope you've entered the competition, because I'd like to win that, but I am not eligible for it. So good luck with that. Thanks so much for joining us wherever you are. Good morning on the west, good evening on the east, and it's about the end of the day here in the middle of the world. So good luck, have fun, and thanks for joining us.